Recall that the general first-order differential equation can be written as y prime equals f of t and y. So the derivative of y equals some function of t and y. If f of ty can be written as a product of the functions m of y and n of t, where m does not depend on t and n does not depend on y, then we say that the differential equation is separable. And so we can divide both sides by m of y to get y prime over m of y equals n of t. So this side is all in y, and the other side is all in t. So we have separated our differential equation. So if we have y prime of t equals y plus 1, then to separate this, we just need to divide by y plus 1. So y prime of t over y plus 1 equals 1. So this is my function of y, and this is my function of t. Alright, another one. What about y prime of t equals yt plus 2t. So first we need to factor out the t. So y prime of t equals t times y plus 2. Then we need to divide both sides by y plus 2. So y prime of t equals t, and we divide by y plus 2. So y prime of t divided by y plus 2 equals t. Now once we have our equation set up as 1 over m of y prime equals n of t, we can rewrite this by using the notation 1 over m of y equals g of y, and n of t equals h of t. So then we have g of y, and we can rewrite y prime as dy over dt, equals h of t. Now we can try to solve our differential equation by multiplying both sides by dt. So g of y dy equals h of t dt. So now we have everything with y on one side and everything with t on the other side. So to solve, we are going to integrate both sides. So this side will be integrated with respect to y, and the other side will be integrated with respect to t. So for example, if we have y prime equals 2ty, is this separable? Yes, because we have a function of t times a function of y. So to separate, we divide both sides by y. So y prime divided by y equals 2t. Then we divide by dt, so dy over y equals 2t dt. And then we integrate both sides. So the integral of dy over y equals the integral of 2t dt, which gives us the natural log of the absolute value of y plus equals t squared plus a constant c. We'll call it c1. And we want to solve for y if possible. So we have the absolute value of y equals e to the t squared plus c1. And this e to the c1 is greater than 0, and it's a constant. So that means that y is equal to plus or minus e to the c1, e to the t squared. So e to the c1 can be any constant except 0, and we're going to rename e to the c1. We're going to rename plus or minus e to the c1 as c. So y equals c e t to the t squared. It's not always the case that we can solve our equation for y. So let's look at an example where we have u prime of x equals negative x over u, and this is separable. We have a function of x times a function of u. So we have u prime of x equals negative x. So u times du over dx equals negative x. Multiplying both sides by dx, we have u du equals negative x dx. Then we're going to integrate both sides. The integral of u du is equal to 1/2 u squared. And the integral of negative x is negative 1/2 x squared plus a constant c. And then we're going to multiply both sides by 2. So u squared equals negative x squared plus 2c1. So we're going to rename 2c1 as c. So u squared equals negative x squared plus c. And so this is an implicit solution because we have u is equal to plus or minus the square root of c minus x squared. So this is not a function of x, so we do not have an explicit solution of y. We have an implicit solution.